believe it or not, let's talk about dividing. Okay? And this is where I want to start. How would you divide 72 into 3,756? No.
Start with the
Long division. How would you do that? No, not how many times 72 goes in. Does 7 go into 3?
No.
Does 7 go into 37? Yes. 5 times. Does 72 go into 3?
No.
Does 72 go into 37?
No.
Does 72 go into 375? 5 times.
5 times.
Now what would you do?
Zero.
No.
Divide
No. No. This is what scares me. Most of you would do this on a over here on the side.
Yeah, no. I would.
A lot of you would do that. That's what I'm discovering. Yes. Okay, hold on. Follow me. Walk with me. Talk with me, people. All right, so what would be the first step here? What would you do? 5 times 2, right?
Yeah.
So can't I just do that here? 5 times 2 is 10.
Whoa.
Right?
Yeah.
Okay. I need to say something before we go any further. For those of you that are secretly in your head saying, I don't care what Mrs. Mahler says, I'm going to write my little numbers over here on the side because that's what I'm comfortable with and that's what I like to do. You're going to have a hard time with today's lesson if you do that. So please pay attention right now, okay? All right, so I'm going to show you side by side what you're used to doing and what your 5th grade teacher should have taught you to do, okay? Or 4th? 3rd?
Second.
No, it's not 2nd. It's 4th grade because my daughter's in 4th grade right now. Okay, so 5 times 2 is 10, carry the 1. 2 times 5 is 10, carry the 1, right? It's exactly what you do. 5 times 7 is 35, plus 1 is 36. Same as you would do over here. Yes, way. Okay, so watch. Now I like a little rhyme. Draw the line and change the sign. So 5 minus, like what I did there? So 5 minus 0 is 5. 7 minus 6 is 1. Now what's my next step? Drop down that 6. Now, cover that up. 7 goes into 15 how many times? Twice. Right? Now, what am I going to multiply first? My ones place, right? 2 times 2 is 4, and 2 times 7 is 14. Draw the line, change the sign. I have a remainder of 12. What does that mean, remainder of 12? But what does that mean? It means that I cannot get 72 into 3,756 another time. I can only get 72 into that number a fraction, exactly 12 out of 72, or 1/6. Okay? All right. We're going to use this to divide polynomials today. Okay? All right. So we're going to start easy and then transition into harder. You're going to see lots of ways that you could do it that is probably easier, but my whole method is start easy so that when we do the hard ones, you'll be more comfortable doing them, right? Okay, so let's start with this. Pencils down. I need everybody to stop. I'll give you plenty of time to write. Don't worry about that. All right, so what would I do if I had something like 4y equals 2x minus 6, and I said, put that into slope-intercept form, what would you do? Divide everybody by 4?
Yeah.
Because that's legal, right? As long as I divide everybody, I'm okay?
Yeah.
We're going to use that same strategy with this. I may not know what this whole polynomial is divided by 3x y squared, but I can simplify if I divide each one of them individually. So I have 9x squared y cubed divided by 3xy squared. Then that's just like homework you did a couple nights ago, right?
Yeah.
Minus 15xy squared over 3xy squared plus 12xy cubed over 3xy squared. Now I can simplify. Equals 9 divided by 3 is just 3. X squared over x is just x. Y cubed over y squared is just y. Minus 15 divided by 3 is 5. X over x is 1, right? And y squared over y squared is just 1. So that stays just like that. What's 12 divided by 3? 4. X over x? 1, right? And y cubed over y squared is just y. I'm going to do one more. Then you guys can copy this down. All right. Same concept. Here's something that looks just like it. What about if I had this? 7 times 4 to the negative 1. Negative exponents are positive fractions. Good job. Negative exponents are positive fractions. So isn't this equivalent to 7 over 1 times 1 over 4?
Yeah.
Which is 7 over 4?
Yeah.
So couldn't I just take this and put it in the denominator of each one of these? Correct? Right? So that's what I'm going to do. So 20 c to the 4th d squared, hold the phone, 20 c to the 4th d squared f all over, what? 4cdf minus 16cf divided by 4cdf plus 4cdf over 4cdf. Why is it 4? Okay, guys, I need the talking to stop. If this, just like over here, I had 7 times 4 to the negative 1, right? Which is the same as 7 over 1 times, we said, negative exponents are positive fractions. So this turned into that. Correct?
Right.
So this right here, please stop, goes in the denominator of each one of these. I should say here. Here, the denominator of that one, denominator of that one, and the denominator of that one. Right?
Yes.
Okay. Everybody with me so far? So now I have 20 divided by 4 is 5. C to the 4th over C is C cubed. D squared over D is D, and F over F is just 1. Minus 4, C over C is 1. I don't have a D in the numerator, I only have 1 in the denominator, so what am I going to do? Keep it there. I can't take it out, right? No, because that would be kind of improper. Just like we wouldn't have a square root in the denominator, we don't have negative exponents. And F over F is just 1. Plus, couldn't you just what? So you're telling me that these are the same thing? Right? See how it doesn't make sense when you do it like that? Okay. So, and this one, what is 4CDF over 4CDF? Yes. This was the most common misconception on the test. I think it looked just like this, if you got this far. 4 plus 4 square root negative 3 over 4. This was my most common answer. These all cancel, right?
Yeah.
To 1, it's 1 plus or minus I root 3. Right? Because 4 divided by 4 is 1.
Yeah, I did that.
Very, very common mistake.
Very common.
Okay. Alrighty, so everybody with me so far? So 4 over 4 is 1, right? C over C is 1. D over D is 1, and F over F is 1. So 1 times 1 times 1 is 1. All right, go ahead and copy that down, guys. Okay, now you guys try these, and then I'll give you the answers. Okay, I think I'm going to show you, just for the heck of it, you can see if you get the same answer. 16 a to the 5th, b cubed, plus 12 a cubed, b to the 4th, minus 20a b to the 5th, all divided by 4ab cubed. Right? All right, so 4ab cubed times what makes 16ab a to the 5th b cubed? 4a to the 4th, right? Plus 3a squared b minus 5, but the b squared,
B squared.
yeah. Could do it that way too, right? But when you have fractions, it gets a little bit more complicated. So you should do it the other way. Okay, so I just wanted to show you that the area model works. Okay, so let's do this one together. So 18 x squared, did I do something wrong? No? 18x squared y divided by what? 9x squared y squared plus 27x cubed y squared z divided by 9x squared y squared, because it does not say in the denominator 2 times. Good. I'm glad. I'm proud. Okay, so 18 divided by 9 is 2. What's left over? In the denominator, because there's a y here, and there's 2 y's in the denominator, so if you cancel the y's, it cancels that too. Right? Plus 27 divided by 9 is 3, with an x left over and a z, and we're done. Questions? 2 over y. How are you guys doing? Okay, let's move on. Ready to move on? Yes. Just do this. This is going to be hard. Nothing compared to what we're going to be doing now. Right now.
Can you do it with the area model?
Okay, so now I want everybody to put pencils down and pay attention. Alright, so I can't divide this the way I was doing with that other method, because if I were to divide x squared by x minus 3, that's a quantity, right? So I can't do it that way. So I have to use long division. But before I use long division, I'm going to show you with the area model. We've already been doing this. Check this out. What times what makes x squared? What normally goes here? Negative 30. X times negative 3 makes what? Negative 3x. Look at this number up here. What do you think this is? So what do you think this is? So this answer is going to be right? It seems harder. Okay, so you can, that's it. That's the answer. Yes, you have to use long division. The reason you have to use long division is because you can't do this with remainders. Okay? We're not going to do any remainders today. We're just going to do straight division. We're not even going to do synthetic division. We're just going to do straight long division today. Okay? What? Okay, so let's do it using long division. I suggest doing this just so that you can check your answer. Alrighty, so x squared plus 7x minus 30 divided by, see, I still like this because to me this is still an area model, right? There's my answer in there, just like in here, right? Only here I just arranged it a little bit differently. Okay, so in my last example on that first page, didn't I just concentrate on that first digit? X goes into x squared how many times? X. Wouldn't I put the x over the x's? That's where they would get placed, right? So let me get rid of this. So x, now when I multiplied back through, didn't I multiply the ones place first, then the tens place? So let's multiply the ones place. X times negative 3 is negative 3x. It goes right underneath the x's, grouped with them. And x times x is x squared. Then I do my silly little saying, draw the line and change the sign. So 7x and 3x make 10x. Oh, look, there's one there too. X goes into 10x how many times? You already know you're right. 10 times negative 3 is, oops, what was my next step over here? Bring down the negative 30. 10 times negative 3 is negative 30. And 10 times 10x, or times x is 10x. Draw the line, change the sign. I have a remainder of 0. Copy that down. All right, you guys try this one. I just think it's helpful to see it. Might as well while I can, right? What would go here? X squared, what would go here? 12. X minus 1. That means that must be x. I'll be quiet now. I don't want to give it up. Okay. Jesus, do you still think this way is harder? But can you see? No.
Well, I can't, but like, you know, it's just like, you know, once, you know, yeah.
Okay. Not that I think it's an alternative method. Just say it's a nice way to see it, right? No, it should not substitute long division. Okay, so x should go here. X times -1 is negative x. X times x is x squared. Draw the line. Change the sign. I get negative 12x plus 12. Negative 12 gives me negative 12 and negative 12x. Draw the line. Change the sign. You guys starting to think it's a little bit easier now? Questions? No. It was, and I drew the line and then changed the sign. Right? Because every time when we, it should be negative 12, and this should be negative 12. And then when I draw the line, I take the opposite. Just like we did on here. Didn't we get, hold on. Hold on. When we had this 360, don't we subtract?
Yeah.
Did I do something wrong on here? You guys are absolutely right. I see it. Negative 12 times negative 12, negative 1, I'm sorry, is positive 12. I see what you're saying now. Now I draw the line and change the sign. It becomes 0. Thank you. Here? We started with, it's so hard to backtrack on these, you know what I mean? All right, so we said, we'll just cover it up. That'll work, right? So x goes into x squared how many times? What times x times something makes x squared? X, right? So we're going to multiply the ones place first. So x times -1 is negative x. And x times x is x squared. Then we draw the line and change the sign. Got it? Erase that, and then uncover that. Uh-oh. How come that went away? That was really odd. I've never done that before. You see what just happened?
Yeah.
I covered it up and then I used my eraser and it erased everything underneath what was underneath it too. Huh, didn't know that. So this becomes negative x and x squared, and draw the line and change the sign. Yes?
Why have you put the plus above after the bottom? Since, like,
Negative 12 times -1 is positive 12.
right.
And then I change the sign.
The first one.
This one.
Yeah.
This one. This one. This one.
Oh, no.
This one.
No. Yeah. Why is it positive?
It was negative and I had to change the sign.
But you can kind of both.
Yes. I should say draw the line and change the sign. Yes. Here, up top, because I had this. Let's start over. This is what I had, right? X, what times x makes negative 12x? Negative 12, okay? So then negative 12 times -1 is positive 12, and negative 12 times x is negative 12x. Draw the line and change the sign. Gives me 0. Okay? Are we good? What about this one? What's different about this one? And what else? So if I normally have I normally have a binomial times a binomial gives me a trinomial, right? So check this out. Wouldn't it have to be a 2 by 3? Oops, this is A. What happened in here? They canceled out, right? Because think about it. This would have to be A squared, right? A squared times A is A cubed. Then what's this? Negative 4A squared. And what would this have to be to cancel it out? Positive 4A squared. Right? So then what's this here? 4A. And then what's this? Negative 16A. Then what's this? Positive 16A. And then what happened here? They canceled out. Then what's this? Because A squared times negative 4 is negative 4A. You don't have to do it this way. I don't want you to do it this way. I'm just showing you how this works. So if I had stuff that canceled out, what does this make right here? 0, right? So this is what I need to do. I need a place marker. See that? No, you don't see it?
Oh, you just took all the...
I don't have an A squared, and I don't have an A. But in order to divide this, just like I did this, I need place markers, right? Remember I told you when you do this in reverse, when we do a 3 by 2, you have boxes and then we can't forget anything because you've got to put something in the box. Well, I need something there in order to divide. So I just put 0. And you'll see why right now. All right, so if I cover all of this up, how many times A times what makes A cubed? A squared. So I put it over as a place marker where A squared should be, right? So A squared times negative 4 is negative 4A squared. I'm going to put it in that place where the A squareds go. Then A squared times A is A cubed. Draw the line. Change the sign. What am I left with? No. 4A squared. Then bring down 0A. But it's just there to hold the place, right? A times what makes 4A squared? 4A. And you'll know pretty quickly if you mess up because look, doesn't this have to be an A here? Because it's in the A place, right? It's a placeholder. 4A times negative 4 is negative 4A. Look, isn't this working out just like this is? 4A times A is 4A squared. Draw the line. Change the sign. What's left here? 4A minus 64. I did that wrong. 4A times negative 4 should be negative. I did that in the last class too. Should be 16A. And I can tell right now because when I was going to multiply it wasn't going to work out, right? This times what makes 4A? This should be 16A, thank you. 16, thank you. Now it works. 16 times negative 4 is negative 64. 16 times A is 16A. Draw the line. Change the sign. I have a 0. Go ahead and copy that down. Challenge yourself. Try this one with both methods. I think this way's fun. I mean, definitely you can't replace it, but it is fun. It's more of a puzzle to me. It just starts to unravel. You know what I mean? That would make this, make it 9b, right? Positive 9b. Okay, that would be it.
Wait, how are you getting
Hmm?
I know the top like C3.
Because, like, how did I get?
Okay, yeah, I know like B and 3.
Because as soon as I have this one, 3b squared,
Yeah.
how did I do it?
I don't know.
But I like this one because it's a puzzle. It makes you think. Once you have this, then b squared times 3 is 3b squared.
And then you need to counteract that, so negative 3b.
Then you need to counteract it,
Well, no, I
exactly.
get that part, but then what's the-
So then, once I have that, something times b makes negative 3b squared. It must be negative
where you
3b.
get the B squared from,
And
you
that's just
separate
your
it one.
answer.
Because you know b squared times b is b cubed. So yeah, you know that this is your answer right here.
So pretty much that's all you would have to do to get the right answer.
Hmm.
And then you can just write it.
If there's no remainder. Okay, so b cubed plus 0b squared plus 0b plus 27 is b plus 3. So we say b squared. This becomes 3b squared and b cubed. You guys seem bored now. Like this is easy.
No.
More like.
Not easy.
Negative 3b to bring down our 0b makes negative 9. Do you guys see how these numbers match up exactly what's in here as I'm doing this? So I get negative 9b and negative 3b squared. Draw the line, change the sign. 9b plus 27. So it's plus 9. I got the same answer, right? Questions, anybody? You guys realize you don't need to do this, right? Okay, so what did you learn today?
How to divide.
How to divide polynomials. What's the difference between, you guys, I need you to not do that. Please stop. Okay, you guys, I'll just have you unpack everything. Please stop shuffling your papers. All right? To a teacher, this is where we tried to get to, so my closure is very important to me. All right? So what's the difference between dividing a monomial and a binomial? Monomial you can do individually, right? But a binomial you have to do it with long division, right? The person next to you is absent. How would you explain how you deal with missing degrees of exponents? You make place markers, right? On your assignment sheet, in order, stay there. And you shouldn't have been shuffling, huh? In order to divide, I would have to what? Okay, I want to see this answer as your exit ticket.